Okay, example 2, we're going to do the same exact thing. If we want to find the absolute max and absolute min of this function on the interval from -1 to 4, we're going to start by taking the derivative, which is 3x squared plus 6x minus 24, and we're going to set that equal to 0. So we have an x squared term and an x term, so we're going to have to factor. First thing I would do is pull out a 3 from everything here. So I have a 3 times x squared to be 3x squared. 3 times 2x would give me 6, and 3 times a -8 would give me -24. So after that, I can do some reverse FOILing. I want to multiply to be a -8 and add up to be a +2, which tells me I must have a positive times a negative to multiply to be a -8, and the bigger number is going to be positive because I'm adding up to be +2. So factors of -8 would be +4 and -2 would multiply to be -8 but add up to be +2. We're going to set that equal to 0. And I have 3 factors, so I could try to find 3 critical numbers for this derivative that we just factored. Well, nothing makes 3 0. What makes x plus 4 0 would be a -4. And what makes x minus 2 0 would be a +2. So I have 2 critical numbers, and I'm going to test that and compare it to the endpoints. So first of all, I want to think about my endpoints. My endpoints are -1 and +4. That's coming from right here. I'm looking on the interval from -1 to 4. We're zooming into the graph, just like what we drew above. We're not looking at the whole graph. We're zooming in, although this is a different shape because it's a different function. So I want to figure out between -1 and 4 what has the highest and lowest y values. So I'm going to compare the endpoints to any critical numbers in between. So I have 2 critical numbers, -4 and 2. Do I have to test both critical numbers? Are they both on my interval of interest? Is -4 between -1 and +4? No. This is great. The less critical numbers on the interval, the less we have to test. So we do not have to test -4. It is not on the interval. So I'm not going to erase it because I don't want to lose any partial credit. It's still a critical number. It's just not on an interval of interest. What about the next one? Between -1 and 4, is 2 between there? Yes, unfortunately it is. And I only say unfortunately because that's more y values that I have to find. So I have 1 critical number on my interval of interest to test and compare to the y values of my endpoint. Again, I'm comparing y values, so I'm plugging into the original function. So if you want to, you could take a minute to plug in. When you plug in -1, you should get 27. When you plug in +2, you get -27. And when you plug in +4, you should get 17. So after just doing some computation, the question is, what's the absolute max and what's the absolute min? So my absolute max between 27, -27, and 17 would be 27. So this time I'm going to write it as a point. My absolute max point would be -1, 27. If it just said what's the location, that would be -1. Usually WebAssign doesn't do that. And then if it said what's the value, you would type in just 27. What about absolute min between the 2 that are left? -27 is definitely lower. So I'm going to write as a point. Absolute min point would be 2, -27. So see if you can do the same thing with the next one. Take the derivative, set it equals 0. You're going to have to factor that one. And then see if you can figure out what the critical numbers are and what's in the interval and what's not.